There are two main ways for taking the integral of tangent of x, which are by applying substitution method and integration by formula. Let us begin by using the first method, which is the usual method, integration by substitution. Before we start solving, let's remember that tangent x is equivalent to sine x divided by cosine x. Therefore, we can rewrite the function in this form. Now, we have two choices for selecting u as our substitution variable, and we want to choose cosine x to be the u. By taking the derivative of this, we get du equal to negative sine x dx. We divide both sides by negative sine x, and these can be canceled out, so that we end up with only dx on the right-hand side. You see, we can now replace this cosine x with u, and this dx can be replaced by du divided by negative sine x. Therefore, we plug them into the equation accordingly. Notice that we can cancel out sine x, and we end up with integral of negative 1 over u du. As we have a negative sign inside the integral, we want to move it to the outside of the integral. Now, we can easily solve this integral, and we know that the result will be the natural log of the absolute value of u. We can now replace u with the original expression, cosine of x, so we will get negative ln absolute value of cosine x. And we are done. But this expression can actually be rearranged to get rid of the negative sign. According to the logarithm properties, we can bring this negative 1 to the exponent of cosine x in this case. The expression cosine x raised to the power of negative 1 is actually the same as 1 over cosine x, and by replacing it, we get natural log of absolute value of 1 over cosine x. Besides that, remember that 1 over cosine x is also the same as secant x, so we replace it as well, and we end up with the natural log of the absolute value of secant x. And we are done. But of course, don't forget to add plus c after we have finished integrating. And we got our final answer. We have discovered the integral of tangent x by using the substitution method. Now, let us proceed to the second method, integration by formula. Just as we did earlier, we first rewrite the function into the integral of sine x divided by cosine x. According to the formula, when we are given a function, let's say f of x, which is in the denominator, and its derivative in the numerator, and we want to find the integral of this particular fraction, it would be the natural log of the absolute value of that function, f of x, plus the constant c. At this point, we have cosine x in the denominator and sine x in the numerator, which is similar to the situation described by the given formula. We know that the derivative of cosine x is equal to negative sine x. And you might be thinking that sine x in the numerator does not have a negative sign in front of it. To overcome this, we manually add the negative sign in front of the sine x. However, we cannot directly add something to the equation. Therefore, we add another negative sign outside of the integral to balance out the negative sign. Now, this part of the integral is exactly the same as the situation described in the formula. In this case, the denominator, cosine x, serves as the function f of x, and the numerator, negative sine x, serves as the derivative, which is the function f prime of x. Therefore, we can solve this part by using the formula directly. And we get the natural log of absolute value of cosine x plus c. But remember that initially we had a negative sign in front of the integral, so we add it in front of our answer as well. You can see that we end up with the same answer as we did earlier by using the previous method. The only difference is that we're left with rearranging this expression to obtain our final answer, so we proceed to rearrange it just exactly as we did earlier. We bring the negative 1 to the exponent of cosine x, replace the cosine x that raised to the power of negative 1 by 1 over cosine x, and finally replace it by secant x. And we got our final answer. Congratulations! We have finally discovered the integral of tangent x using both methods, substitution and the formula. Drop a comment below if you are struggling with any part of the calculations. And of course, let me know if you have other alternative solutions to this question. I spend hours making videos explaining math topics, and all I ask for in return is simply to hit the like and subscribe button. Thanks for watching. See you guys in the next video.